This is linear algebra. We're gonna do cofactor expansion. So previous video, we're gonna define the determinant of general metric, n by n metric. So we did some example with 2 by 2, 3 by 3, and 4 by 4 metric. So this is another technique to find determinant of metric A, guys. We're gonna use cofactor expansion. Okay, so metric A is n by n matrix. So determinant is defined only n by n matrix, guys. Keep in mind, we did determinant A gonna be A11, first row, first column, entry, guys, right here. And determinant A11, second term is negative A12, determinant 1, 2, and all the way first row, okay? So let's quick review. Excuse me. This is a 3 by 3 metric, guys, 3 by 3. So how can define determinant A? So we did A11, first row, first column, determinant A11, which meaning is you deleting first row, first column. Second is A12, determinant A12, A13, determinant 1, 3. That's what we're going to define metric A with the 3 by 3 size, okay? So this is looks a little messy. Here's a positive, negative, positive, negative. So we're gonna clear up this definition by using the cofactor. So what is cofactor? Cofactor gonna be when you give the metric, that's the definition of cofactor ij. So Cij negative 1, 1 plus j, determinant aij. So we clean up a little bit of definition of determinant A, but there's no huge difference. Guys, here is determinant A. We'll write down this one. Positive, negative, positive, negative. So kind of confused. So we're gonna put this thing is gonna be cofactor 1, 1. 1, 1 cofactor. And negative, and this one gonna be cofactor 1, 2. So C12 is going to be definition is negative 1, 1 plus 2, determinant A12. 1 plus 2 is odd number, negative 1, 3. That's the negative. So this one going to be negative determinant A12. That's why we're going to clean up the negative there. Guys, make sense? So IJ cofactor is they include the sign, but how we did it exactly same, just to clean up the notation, guys, here. Yeah, so with cofactor expansion, we're gonna have really powerful theorem right here. So determinant A, how can compute determinant A? We're gonna use it first row. But this theorem give, you can use, guys, determinant A, you can use any row, any column to expand cofactor expansion. So this theorem gives a lot of freedom. You can use any row, any column to compute determinant A. So for example, guys, very popular theorem, guys, look at this. Here is n by n matrix. You're gonna pick the any row. So any row, any column. So I gonna expansion cross I row. So we're gonna expansion this one. It's fine. You can expand the i's row. So I1, that's the first entry, C1I, AI2, C1I2. So all the way there, you're going to expand cross the i's row, one first row, second or third, whatever you want to pick, you can expand it. So same thing is going to be columns. So you're going to pick any column, first column, second column, J's column. So you're going to expand the J's column to compute determinant. So you have understand how gonna find determinant A, but there's no restrict first row, second row, first column, second column. You can pick any row and column to compute determinant A. Okay, consider this example, guys. So we're gonna find determinant A. That's gonna be 3 by 3. Previous video, we're gonna use the first row. which row, which column you're going to use to find the determinant A. You have any idea? Here is the first row. Here is the second row. Here is the third row. I want to use the third row. Why? Why? We will expand across row 3. Why, guys? Why? Because they have entry gonna be 0. 2 0 is right there. So let's see the definition of A. Third row ID. So A31, C31 plus A32, C32 plus A33, C33. Good news is, guys, right here, guys, this one is a 0. So 0 times C31, A32, negative 2, C32 plus A330, C33. Oh, you don't have to find cofactor 31 because 0 times is something always 0. This is a 0. This is a 0. You only find negative 2, C32. Guys, make sense? So what is definition of C32 gonna be? Negative 1, 3 plus 2, determinant A32. Oh, so this is odd number 5. That's the negative one. So determinant A32. So we're going to find negative 2, negative 1, determinant A32. Everything make sense? So this one is 2, determinant A32. Okay, now we're going to find this one. Now we have find, what do you have find this one? What is mean by that? So let's find determinant A32. This one is gonna be, you're gonna remove or delete it, third column, oh no, third row, second column. Okay, so let's go this one. So determinant A gonna be 2 times determinant A32. So we're gonna delete the third row, second column, 2, did you say 2, 1, 0, 2, negative 1. So let's calculate it. This is gonna be 2 times this one, negative 2 minus 0. This one is 0. So you find that's gonna be, oh no, guys, I'm wrong, right? This one is negative 1, negative 1 minus 0. That's gonna be negative 2. Guys, make sense? So which column row you're gonna pick depends on the how many 0 in the those row and column. So this one is another way you see this one. You can pick the column here, third column, because they have a 2 0 right there, guys. It's up to you which one you're gonna pick, but make sure looking for the row and column which has most have zeros, guys. Okay, let's practice this 3 by 3 metric. How can compute determinant this metric, guys? Okay, so you're gonna see first is looking for each column, each row, which column and row has the most zeros. Okay, this column is 2 zeros here. This column is 1. This one is 1. So I'm gonna pick the column 1. That's how I'm gonna expand down the column 1, guys. So determinant A gonna be, guys, look at this one. So A11, C11, A12, C12, A13, C13. That's you're gonna expand it, right? But good news is A11 is a 4. Then minus 1, 1 plus 1, determinant A11. But good news is here, guys, this one is 0. This is 0, right? So I don't have to calculate anything. So you're going to do this one. So what you have find it is 4, negative 1 square. We're going to find determinant A11. So A11 is first row, first column. So you have 4, 1, 2, negative 1, 1, 0. So this one is 4. 2 times 0 is 0, minus 1. That's gonna be 4. That's you're gonna find it, guys. Guys, it makes sense? So just looking for the column and row, which has most zeros, guys. Okay, this time is you have 4 by 4 metric, more bigger metric, right? So how can they find determinant A? Can you decide which column, which row you're gonna expand? All right, where is here? First row has 2 zeros. Second row doesn't have zeros. Third row has 3 zeros, right? So we're going to expand the third row, okay? So 3. C, here is 3, 1. Plus 0, C, 3, 2. Plus 0, C, 3, 3. Plus 0, C, 4, 4. So everything is gone, only 3, C, 3, 1. C31 is gonna be 3, negative 1, 3 plus 1, determinant A31. So 3 plus 1 is even number. That's gonna be negative 1, even number, always 1. So 3, determinant A31. So what is A31? A31 meaning is third row, first column. So you have A31. I'm gonna make a matrix, guys, here. So 0, 0, 4, A, 3, negative 4, 3, 2, 2, 1, 8. So we want to find this determinant. Okay, also same rule you can apply. So A, 3, 1. A, 3, 1. Let's looking for row and column has most 0. Oh, here's the winner. First row, right? So 0, what is it? C1, 1. 0, C1, 2. 4, C1, 3. So this one is going to be 4, C1, 3. Another way, 4, negative 1, 1 plus 3. Determinant, another determinant here is A1, 3. This one talking about this metric, okay, guys? So this one is a 4 times 1. Determinant 1, 3. So first row, third column. This one going to be A3, 2, 1. So you have 4 times 1. This one is A minus 6. So this one is a 4 times 1 times 2. That's going to be 8. So you find determinant of submetric. Now go back to original equation. It's 3 times. This one is 8. That's the 24. Okay? All right. One more thing for this section, guys. We want to compute this metric, determinant of this metric, guys. Can you see something different from previous one? So can you see that? What is notice, guys? Diagonal. Diagonal have number below the diagonal. That's the 0. That's very special metric. We call this one is triangular metric. You noticed that, right? So let's do the find determinant, okay? How can find the determinant? I'm gonna decide, you guys decide the third row, first column, it's up to you, but I'm gonna use the first column. 1, C, 1, 1. But other thing is 0, you don't worry about it, which meaning is 1, negative 1, 1 plus 1, determinant A1, 1. So 1 times first row, first column. That's gonna be 4, 0, 0, negative 2. So this one is 1 times 4 times negative 2. That's gonna be negative 8. Can you notice something here, guys? Can you notice something? So I'm gonna rewrite it, guys. Matrix A looks like a triangular matrix, looks like 1, 2, negative 3, 0, 4, 0, 0, 0, negative 2. How can find the negative 8? Anyone can notice it? Here is 1 times 4 times negative 2. 1 times 4 times negative 2. So determinant A gonna be 1 times 4 times negative 2. So that's the negative 8. That's the another way you're gonna find this one, guys. Okay, so that's the one fun theorem right there. When you A is triangular matrix, so meaning is diagonal entry gonna be number, below the diagonal is 0, then determinant A is just times all the entry on the diagonal. That's you gonna find determinant A. We just show it, right? Okay, let's have the example about this theorem. So this one is metric. Here is metric gonna be 4 by 4. Guys, check it. Don't just jump in, find the determinant. Look at this one. This triangular metric here is right there. That's the entry in the main diagonal, and below the diagonal, all the 0. So determinant of this matrix is very easy. 3 times, 2 times, 4 times, -3. That you find the determinant of this matrix. That's going to be -72. If you want to check by the definition of determinant, you can check it, guys.